Now hello, in this video titled Circumcenter, I am going to go over examples on how to use the circumcenter of a triangle to solve equations and find lengths of segments on the triangle. Let's again first go over what the definition of a circumcenter is. Now the circumcenter on a triangle is created when we have perpendicular bisectors on the sides of a triangle, again intersecting at a common point. That is called the circumcenter. Now the uniqueness about the circumcenter, the usefulness about the circumcenter, is that the circumcenter is always equal distance, meaning the same distance from the vertices of the triangle. So for example, let's look at a triangle as you see right here, and let's identify a couple of things about this. Let's start off first with the circumcenter. The circumcenter is going to be again this letter P, and the way we create and I find this circumcenter is that we look at the sides on the triangle and find the perpendicular bisector. So we look for where the middle point would be and making a line at a 90-degree angle again to this space right here, as you see right there indicated by this, making a 90-degree angle, and doing the same thing with all the other ones, with all the other bases. This point that they intersect at is called the circumcenter. So in this example, our circumcenter is going to be the point P. Now with that point being again, being the circumcenter, a couple of things that are equal distance. The distance from point P to point B, which again is the vertices. Our vertices are these 3 points here. Let me do them in blue: B, A, and C. Those vertices, the distance from the circumcenter to those vertices are going to be equal distance. So the distance from point P to B is the same distance as point P to C, which is the same distance from point P to A. And then, as you can see, since these points, again, these points are in the middle of each respective side, the segment that connects two vertices is going to be made into two equal parts. So the distance from B to C is equal to twice the distance from B to E, or better said, the distance from B to C is just going to equal to, again, is half the distance from E to the 2 points, E to B or E to C. And the same thing again down here. F is going to be in the middle, and this long segment can be broken up into two equal parts, and the same thing up here. D is going to be exactly in the middle. And our perpendicular, and which then makes our perpendicular bisectors the following. PD is perpendicular to AB. PE is perpendicular to BC, and P to F is going to be perpendicular from point A to point C. So these are perpendicular bisectors. So let's see how we can use the Circumcenter again to figuring out side links and setting up equations again and all that other good stuff that we do. So let's look at the first example. So here we have again that we're looking to start on with RS. We want to know what the distance from point R to point S is. Well, point R is located here, and we want to know where that point S is going to be. So first again, even though it's not stated, point W is the circumcenter. So we know that W is called the circumcenter, and all of these points here are midpoints. Let me highlight them in red. So this is a midpoint, V is a midpoint, and T is a midpoint. So we're going to figure out the distance from R to S. Well, since U is in the middle, the distance from R to U is 19. Therefore, the distance from U to S is also going to be 19. And 19 plus 19 is equal to 38. So that is the distance from R to S. It's going to be 38 units. On number 2, we want to figure out the distance from T to Q. Well, the distance from T to Q, let's find T right here. T to Q, that is half of the distance from R to S. Again, the total distance from point R to point S is 32. And since T is in the middle, dividing 32 by 2 is going to give us the lengths of these two segments. So which is 16 and 16. So the distance from T to Q is going to equal to 16. So if I get 32, like I said, and I divide it into 2 equal parts, I get 16. So that's the distance from T to Q, because again, T is in the middle. Now let's look at the distance from W to S. Well, W again is the circumcenter. So W to any of the vertices, let me highlight the vertices, any of these vertices is going to be equal distance. So if the distance from W to Q, as you see right here, is equal to 24, that means that all of the distance from W to the vertices are all going to be 24. So W to S is 24, and W to R is also going to be 24. Now our next one is Q to V. Well, from point Q, where's point Q? Here we go, to point V. Well, that's congruent because again, V is in the middle. That's the same distance as V to S. So that's also going to equal to 21 units. Now here's when it gets a little bit interesting. We want to know the distance from T to W. So if we want to know the distance from the circumcenter to this midpoint, again to these midpoints here, to these points in red, then that's going to require us to use Pythagoras' theorem. So we want to know what the distance is to this right here, okay? Now remember, T is in the middle, but this line right here that I have in green is also perpendicular to, again, these bases. So these again are perpendicular, and this angle right here again is perpendicular, which means that we create again 90-degree angles, and specifically we create right triangles. So if I draw that triangle like this, and let me label T right there to W, to the circumcenter, and then we have this point right there, R. I see that the distance from R to T is 16 units, and the distance from T to R, which is to the vertex, is going to be again 24. Wrong place. W to R is 24. So to figure out the missing side, figure out the length from W to T, I'm going to have to use again the Pythagorean theorem. A squared plus B squared is equal to C squared. Where this again is my 90-degree angle, and opposite of my 90-degree angle is letter C. So we have our point A, our point B, and we're going to figure out again this measurement of value of B, variable B, by plugging in 16 for the letter A. B is going to be my unknown, and 24 for the letter C. Now I am going to need some help on this. So wrong one. So 16 to the second power is 256. 24 to the second power, oops, is 576. I forgot what I just said. 256 and 576. And 576. I solve B by doing again letters to the left, numbers to the right. So I'm going to move 256, and I'm going to get B to the second power to equal to, what is this? This is 0, 2, 3, 320. So you see 320. Now, however, B is being raised to the second power. So B squared is equal to 320. So what I need to do is I need to take the square root of that so I can cancel out, again, this square. So taking the square root of that, that's going to give me more than likely some irrational number, and it does. It equals to 17.8. The distance from T to W is going to be 17.8. So this distance right here, let me put it in black now. This distance right here is going to be 17.8. And the way we're going to figure out the distance from W to V is the exact same way. So let me erase all of this, okay? And this one is easier to see that we have a right triangle. As you see right here, we have this distance. So it's easier to see that we have this right triangle here, where we have V, we have W, and we have Q. Again, this diagonal side is going to be 24 like it was last time. However, this time, our base, which is from Q to V, is also going to be 21. You could also use this one, again, as the same triangle as what I draw right here. Your diagonal side is going to be 24. So if you use S instead of Q, is the exact same thing. And this is going to be 21 now. So from Pythagoras' theorem of A squared plus B squared is equal to C squared, on these type of examples, what you're going to notice that's happening here, just to give you a little shortcut, is that the way we're going to figure out this missing side when we have to use Pythagoras' theorem is that we're going to have to subtract the larger number, 24, to the second power, which is a C, by the smaller value of A to the second power. And that's how we're going to figure out, again, the length of that side, that midpoint to the circumcenter, by using this right here. So this is going to probably be a shortcut, and will work again anytime we're doing that, because that's usually the only number that's missing right here, because we are going to find that all the other distance are going to be from the circumcenter to the vertices are equal distance. And around the triangle, well, around the triangle, again, we just simply end up with half of those values. So we end up again using that formula there to figure out what that side, in this case this side right here, is going to equal to. So with C being again this diagonal side being the bigger number, 24 to the second power minus 21 to the second power, I can just simply plug this into the calculator and get the following. So we're going to have the square root of 24, which again, and we're going to take away 21 to the second power. So that estimated to 11.6. So B is equal to 11.6. So let's look at another triangle right here. Again, so Z is the circumcenter of TUV, and we want to find the missing angles. So let me highlight Z. Let me highlight the vertices. So these again are the vertices in blue. So the vertices, the corner of the triangle. So that means that from the circumcenter to those vertices, they're all going to be equal distance. Sorry, I'm trying to make a straight line here and not coming out very well. There we go, much better. So those three segments are equal distance. So they're all going to be 21. Since as you see here, that's 21, then all of those sides are going to equal to 21. Now we want to start by first figuring out the distance from T to U. So let's see, let's find T. T is located here all the way to U, which is all the way over there. Well, let me highlight these points. Since X, W, and Y are midpoints, they're located exactly in the middle, then that means that this side over here is also going to be 19. So this is also going to be 19. So the distance from T to U would be 19 plus 19, which is equal to a total of 38. So 19 plus 19, 38. Now let's look at the distance from V to Y, so to the middle. From the corner to the middle of this long segment here, that's going to equal to half of the entire distance. So if I get 34 and I divide it by 2, that's going to equal to 17. So these two sections are 17. So V to Y is 17. Now U to Z. Well, U is the vertice to Z to our circumcenter. So those are all congruent. So that's going to be 21. Now the distance from W to V. Well, W is here to V right there. Well, normally what we have to do is just simply divide this entire length from T to V by 2, but we don't know what that measurement is. Or if we knew that what this measurement was, we could figure out that measurement as well, because again, they're going to be congruent. These two sides right there are congruent. But since we don't know that, what we're going to use again is the fact that this segment from the circumcenter to this midpoint is a perpendicular bisector. So it's going to intersect at this 90-degree angle. So the way we're going to figure out again this distance right here, all right, this black distance right there, is by using this shortcut, this formula, the Pythagorean theorem, solved again for one of the bases. So b squared will equal to c squared minus a squared. And the numbers that go inside this formula for c and a is quite simple. You put the bigger number for c, so 21 to the second power, minus the smaller number 15 to the second power. So you're simply going to take the square root of that there. So we'll need the use of a calculator here, so let me get some help here. So we have the square root. We're going to get 21 to the second power and we're going to subtract that by 15 to the second power, which approximates to 14.7. So 14.7. So W to V is equal to 14.7. And now TV, from point T to point V. Well, since this, we just found that W to V is 14.7, then T to W is also going to be 14.7, because remember, W is in the middle. So 14.7 plus 14.7 is equal to 29.4. So that is your missing measurements. So now let's look at solving an equation to find the segment length. So here we now want to figure out the distance from B to C. So let me highlight this, from B to C. Well, the distance from B to C is going to equal the distance from B to E plus the distance from E to C. So what I need to do is first figure out the value of X, plug it in here, and because E is in the middle, these two sides are equal, and just simply add that number twice or multiply that solution by 2. So let me write that stuff. So first I need to solve for X. Second, I need to plug in that value of X. And third, I just need to double that number, because these two segments are going to be equal. So let's start by setting up our equation. Well, again, like I said, since this segment here in black is equal to this segment right here in blue, then 13x minus 51 is going to equal to 10x minus 33. So with letters to the left, I subtract 10x. Numbers to the right, I add 51. And I get positive 3x is equal to positive 18. I divide by 3, and x is equal to 6. X is going to equal to 6. So now that I've solved for x, okay, I can now plug it in. Let's plug it into this bottom one right there. It doesn't matter, because again, these two things are equal. This black line and the blue line are equal. So let's plug it into that one. That one's simple to plug in, because 10 times 6, that's simple, that's 60. And 60 minus 33, that's equal to 27. So the distance right here in blue is 27 units, which means that this distance over here in black is also 27 units. So the distance from B all the way to C will be 27 plus 27, which is equal to 54. So that's our solution. Let's use a different example now with the circumcenter. So now look at here again. P is our circumcenter, which means again that the distance from that circumcenter to the vertice of B, this blue line here, is going to equal to the same distance from the circumcenter to one of the other vertices, like in this case C. So these two lines, this blue line and this red line, are congruent. They're equal. So that's how I'm going to set up my equation. And the way I'm going to figure out the distance from A to P, which again A to P, which is that distance right there, is to plug in the value of X with, again, the solution to this equation. So 11x minus 14 will equal to 6x plus 1. And again, by plugging it into either the top one or the bottom one would be equivalent, because again, these two things are equal to each other. And the distance from the circumcenter to A to this one right here is the same thing as the distance from P to B, the red line, the blue line, and the same as the distance from P to C, the red line. So I just simply have to do two things. I have to simply solve for x and then plug in the x. So with letters to the left and numbers to the right, I'm going to subtract 6x and I'm going to add 14. And we get 5x is equal to 15. Divide by 5. X is equal to 3. So let's plug it into the bottom one. Let's plug it into that one right there. So PC is equal to 6 times 3 plus 1. So PC is equal to 18, 19. So that distance right here is 19. And because that's the same distance as P to B, the blue one, this is also equal to 19. Which means that the distance from P to A is also 19. Any distance from the circumcenter to the vertices are all going to be the same. So that's our solution. The distance from P to A is also 19. Moving on to our third example, or I'm sorry, our 10th. This is now our 10th example, or third when we have to set up equations. Our third example about solving equations. Again, we're given the situation where we're trying to figure out the distance from F to C, right? So we want to know this distance from point F to point C. Well, the information they give us is this length right here, which is from the circumcenter to the vertice. And the relationship between the circumcenter and all the vertices is that they're all the same. So the distance of the red line that I'm just drawing right here is the same distance as the blue line, and the distance from the green line. So all of these three lines, the blue, the red, and the green, are all equal in length. So let's first figure out how long that line is. And let's see if that could take us closer on how to figure out the distance from F to C. Well, since the blue line and the red line are equal, because again they're connected to the circumcenter from the vertices, I can set up my equation by setting them equal to each other. So 3x plus 2 is going to equal to 5x minus 16. And with letters to the left and numbers to the right, I would subtract 5x and subtract 2. We would get negative 2x is equal to negative 18. And then dividing by negative 2, we get that the value of x is equal to 9. So let me plug in that value into the blue line. So the blue line is from point A to point P, which is 3 times this value of x plus 2. I'm going to replace the x again with 9. And we get 27 plus 2, which is equal to 29. So the distance from point A to point P is equal to 29. So that is 29, which is the same distance as P to B, the red line. So that's also going to be 29. And the green line is also 29. So the way we're going to figure out the distance of F to C, well, as you see here, let me get a different color pen. Let me get a purple one here. The distance we're going to figure out for F to C is by drawing ourselves a right triangle. And using again this formula of a squared plus b squared is equal to c squared, the Pythagorean theorem, I can solve it again for the missing base and simply use this right here. So use this solved form of a squared plus b squared is equal to c squared. I just simply have to do this, all right? Where c, just remember that c is always going to be the largest number, the bigger number of the two, and a is going to be the smaller number. So we end up finding out the distance from f to c. The distance of f to c to be the square root of 29, since 29 is bigger than 14, and 14 squared. So let's see, let's use our calculator for this. So the square root, sorry, let me hit enter. The square root of 29 minus 14 to the second power, which is approximately 25.4. So that's the distance from there, 29.4. So that's our solution. So this one was, again, a little bit longer. It took 3 steps. But the key thing that I want you to understand when it comes to figuring out, again, the distance from the midpoint to the one of the midpoints to the circumcenter, you have to use, again, this theorem there. Or if you're using that number right here to figure out like the base, then again you use that formula like right there, like the one we just did right now. Again, that concludes my examples on how to use the circumcenter to solve equations and find segment lengths. I hope this was very helpful. And like usual, if you haven't subscribed to my YouTube channel, please make sure that you do so you can get the latest notifications on video updates. Again, thank you for watching, and I hope you have a great day.